Hello everyone. In this lecture, we are going to discuss the application of double integral. In that, first of all, we are discussing area by double integration using the Cartesian coordinates. And we know that the Cartesian coordinates are nothing but x and y. First of all, let us see the formulas for to find the areas. And there are the two formulas for to find the area. You can observe in the first formula, your inside integral limits are from f1 of x to f2 of x, that is both are the function of x, and outside integral moving constantly, that is from a to b. And here the main things is the value of f of xy is equals to 1 and dy into dx as it is. Similarly, in the second formula, the inside integral limits are from g1 of y to g2 of y, that means both are the function of y, and outside limit moving constantly, that is from c to d. And also here value of f of xy is same, that is 1, and dx dy is as it is. And to solve the example, we are using only one formula, and that formula we are selecting on the basis of a region of integration. Now we are solving one example, and the example is find the area between the curve y square equals to 4x and y equals to 2x minus 4. First of all, we are concentrating on our given things, and the given things, that is given curves, are y square equals to 4x, that is nothing but equation of parabola, and another curve, that is y equals to 2x minus 4, that is nothing but equation of straight line. Now first of all, we are plotting these curves on the graph, and if I plot this curve on the graph, then this will be the figure. So in this figure you can observe this curve is nothing but equation of parabola, that is y square equals to 4x, and this straight line is nothing but y equals to 2x minus 4. And mainly there are three intersection points in this figure, that is this and this. This point, that is point 2 0, we can find easily by putting y equals to 0 in that equation of line, and that means this line intersecting to the x-axis at the point 2 0. And for to find these two intersection point, that is this and this, we have to solve this two equation, that is y equals to 2x minus 4 and y square equals to 4x simultaneously. So here I am finding the intersection point, and I am considering y square equals to 4x and y equals to 2x minus 4, that is two equation. So I am putting the value of y from second equation in equation 1, that is 2x minus 4 bracket square equals to 4x. Now after taking the square of this bracket, we'll get 4x square minus 16x plus 16 equals to 4x. And after solving this, that is we are dividing whole equation by 4, we'll get x square minus 4x plus 4 equals to x. Now by taking this x to LHS side, we'll get x square minus 5x plus 4 equals to 0. That is one quadratic equation. After solving this quadratic equation, we'll get the value of x is 1 and 4. And if I put x equals to 1 in one of this equation, I am putting in first equation, that is y square equals to 4, I will get y square equals to 4 into value of x is 1, then I will get y equals to minus 2. And similarly, if I put x equals to 4 in the same equation, that is y square equals to 4x and value of x is 4, so y square equals to 4 into 4 will get y square equals to 16, then y equals to 4. And here I am considering minus sign because our point is in fourth quadrant, and in the fourth quadrant our y values will be negative, and therefore I am considering here y equals to minus 2. Similarly, here I am considering only plus value because this point will be in first quadrant, and in the first quadrant the value of y will be positive, and therefore there are two intersection points, that is 1 minus 2 and 4 4, that is 1 minus 2 and 4 4. So obviously the positive point, that is 4 4, is in the first quadrant, that is this point will be 4 4, and this point is 1 minus 2 because this point is in fourth quadrant, and in the fourth quadrant x is positive and y is negative. Now our target is to find the area between these two curve, that is y square equals to 4x and y equals to 2x minus 4. That means we have to find the area between these two curves, that is we have to find the area of this region, and for that we have to use one of the formula from that. And here for this region, if I consider horizontal strip, then I can find the limit of integration easily, because using only one strip we can find the limit of integration. But if I consider supposed to be vertical strip, then I have to divide your region into two parts and we have to find the limits of integration two times for the separate region. And that is why we are considering horizontal strip, so that we can find our limit of integration using only one strip. So here I am considering one strip, that is strip AB, that I mentioned here. Consider the horizontal strip parallel to the x-axis. Now I am finding the limit of integration along this strip, and therefore we can observe the lower end of this strip will touching at the curve y square equals to 4x, and the same strip will touching at y equals to 2x minus 4 at upper side. That is, lower end of this strip is touching at parabola and upper end of this strip is touching at this line. And we have to vary our x variable, so that we have to write this equation of parabola in terms of x, and we have to write this equation of line in terms of x. So first of all, we are writing this equation y square equals to 4x as x equals to y square upon 4. Similarly, we want this equation of line also, that is x equals to y plus 4 upon 2. So this same equation of line I can write as x equals to y plus 4 upon 2. Therefore x varies from x equals to y square upon 4 to the x equals to y plus 4 upon 2. And that I mention here, x varies from x equals to y square upon 4 to x equals to y plus 4 upon 2. Now we have to vary our y constantly, and we can observe this region is starting from this point and ending at this point, so that the y coordinates of this point is -2 and the y coordinate of this point is 4. That means our y is varying from -2 to 4, and that I mention here, y varies from y equals to -2 to y equals to 4. Now we got the limit, so using that limit we can find now area. Before that, we can observe our x varies from the function of y into the function of y. That means our x is varying in terms of y, and y is moving constantly, that is -2 to 4. That means we have to use a second formula. In that second formula, you can observe here inside integral is moving from g1 of y, that is function of y, to function of y, and outside integral is constant. Therefore I am using the second formula, that is from the integral y equals to -2 to y equals to 4, and inside integral is x equals to y square upon 4 to x equals to y plus 4 upon 2, and the value of f of xy is 1 dx into dy. And after solving this double integral, we will get the area. And therefore first of all we are solving this inside integral. This inside integral is with respect to x, and the integration of 1 with respect to x is only x, and the upper integral, that is x equals to y plus 4 upon 2, and the lower integral, that is x equals to y square upon 4, and outside integral, that is y equals to -2 to y equals to 4 as it is. Now we are putting upper limit and lower limit simultaneously. So if I put upper limit, we'll get y plus 4 upon 2 minus lower limit, that is x equals to y square upon 4, that is y square upon 4. First of all, we are simplifying this. We will get y upon 2 plus 2 minus y square upon 4. Now we have to take integration of this term with respect to y. So in the first term 1 by 2 will be constant, so I am taking outside, and integration of y is y square upon 2 plus, as it is 2 is constant and integration of constant is only y, so 2y is here, minus 1 by 4 will be constant, so I am taking it outside, and the integration of y square is nothing but y cube upon 3, and the upper limit y equals to 4, and lower limit y equals to minus 2 as it is. Now we are putting upper limit and lower limit simultaneously. So if I put upper limit, that is y equals to 4, then I will get 1 by 2. Instead of y I am putting 4, that is 4 square upon 2 plus 2. Instead of y I am putting 4 minus 1 by 4 as it is. Instead of y cube I am putting 4 cube upon 3 as it is. If I put lower limit, that is y equals to minus 2, I will get 1 by 2 as it is. Instead of y I am putting minus 2 bracket square upon 2 plus 2 into minus 2 instead of y plus 1 upon 4 into minus 2 cube upon 3. After solving this first bracket, I am getting 4 plus 8 minus 16 upon 3 by calculating this, minus into, if I solve this bracket, I will get 1 minus 4 plus 2 by 3, and after simplifying or calculating these values I will get 1. So our area is 1, and that is our final answer. Thank you.